Afternoon, everyone. We're going to get started in just a few minutes. Corey, have you made it in the room yet?
Yes, I have. I'm here.
Okay, I just want to check your audio. It's good. Okay, guys, we're going to get started. I'm Ronnie Cox. I'm your moderator for this session, and Mary Edcock is our co-moderator. And today's session is going to be brought to you by Darnell and Corey. Darnell is a special collections and archives metadata librarian and associate professor at the University of Nevada, Las Vegas. As the lead metadata and semantic web strategist, he oversees Wikidata-driven metadata initiatives, large-scale remediation projects, and metadata workflows and documentation. He co-authored linked data for the Perplexed Librarian. Sounds like I might need to read that one. And conducts research on metadata and resources discovery in digital libraries, ethical representations, and public knowledge graphs, and data integrations. His work focuses on linked data implementations, graph-based visualization tools, metadata reconciliation services, workflow optimization, and systems interoperability. He holds an MLIS from San Jose State University, specializing in information organization, description, and analysis and retrieval. Corey Lampert is the head of digital collections in the Special Collections and Archives Division of UNLV University Library. She is responsible for leading the library team responsible for digitalization of cultural heritage materials, metadata creation for discovery and linked data creation, and the administration of the library's open source repository of digital special collection materials. She has been a co-PI on the National Digital Newspapers 2014 to 2020 grant to digitalize historical newspapers from every county in Nevada, and she is the co-author of the book Linked Data for the Perplexed Librarian, ALA editions. She serves in leadership roles in the International Federation of Library Association and the City of Las Vegas Open Data Initiative. She is also interested in mentoring and supporting of early career information professionals. The floor is yours.
Thanks very much. I'm going to kick it off here, and I believe Darnell will be running the slides. Um, Thank you so much for joining us today. We're really excited to be here. Today's session is going to begin with some background on the collection that grew into the linked data project that we're going to discuss. So Darnell, you can advance to slide 2. It all started in 2014 with a grant that we had to identify and digitize collections documenting the African American experience in Las Vegas. So during the last month of that grant project, we received a portion of the Clinton Wright Photograph Collection, which documented Las Vegas's historic Westside. Unfortunately, because it was the last month of the grant, there was no time to do a lengthy digitization project. And the only access we were able to provide to the collection at that time was through contact sheets with titles of the shoot from the photographer. Because this was not the approach we ideally would have taken, we always intended to go back and do more. The west side of Las Vegas is a historically African American neighborhood, and it's shaped by some of Las Vegas's most important civic leaders, such as Dr. Charles West. Dr. West was a major figure in this community's history, and he ran the Las Vegas Voice newspaper. And by the year 2020, UNLV had come a long way from the first grant. We had hired archivists to create standards compliant finding aids. We'd done a public exhibit on the Black community in Las Vegas. And we had new high quality digitization equipment in our lab that could handle film materials. So when we completed the digitization of the Las Vegas Voice newspaper back in 2022, it was time to go back and prioritize better access to the Clinton Wright Photograph Collection. No other archive in Las Vegas does a better job in capturing the community's lived experience through this visual documentation. So today we're going to do a walkthrough of our project, including lots of technical details. But first, I would like to introduce a key component of this work, the student labor that's driving much of the innovation on this project. Next slide. The original plan for the Clinton Wright Photograph Collection was to write another grant and hire a project manager and metadata specialist to enhance the metadata. But when that grant was not funded, we needed to shift gears. And instead, we decided to work with resources we already had access to, 5 student assistant positions that work roughly 12 hours per week in our department. These students are mostly undergrads and they do digital capture and metadata work. And while some might feel this is beyond what can or should be taught and managed in the student environment, we at UNLV have had great success in working with a team of students over multiple years. The students have been responsible for the digitization of complex film collections and the creation of high quality metadata. In fact, students have enhanced our workflows through feedback and suggestions. And in the case of metadata, they are adding significant value to the collection by researching and expressing relationships that they're finding in the data. Students have also taken these skills and done scholarly presentations, open house demonstrations, and news appearances as sort of our undergrad experts on the project. And this has also been really meaningful for them. Now I'm going to pass it over to Darnell to give us an introduction to the linked data approach to this.
Thanks, Corey. So I just wanted to give you guys a little background and some origin story facts about this project. And it was really interesting. The information kind of grew organically as we dug into these collections, starting with the Clinton Wright photographs. But as we started working and finding and digging into this collection, we started to learn a lot about some key figures and just some key players in the community started to emerge as we started to do this work. So I want to give you a little background. And really, all of this work really starts and is centered around Dr. Charles West. Let me give you a little background about him. Charles I. West was born in Washington, D.C. in 1908, and he earned his medical degree from Howard University in 1933. After completing his medical training in Kansas City, Missouri, and Tulsa, Oklahoma, he served as a field surgeon during World War II, where he was wounded in France. Following his military service, he further studied at the London Tropical School of Medicine before returning to the United States. In 1954, Dr. West made history as the first licensed Black medical doctor in Las Vegas, but his impact extended far beyond medicine. He quietly, behind the scenes, advanced civil rights efforts in Las Vegas. And most importantly, he founded the Las Vegas Voice, the state's first Black-owned newspaper, which served as a powerful voice for the Westside Las Vegas community. Also, a key to mention was his wife, Dottie West, who was a dancer, singer, and businesswoman. She also was the mother of John P. West, who also served as the newspaper's editor. And she also worked as the editorial consultant for the paper. John P. West was a heavyweight in his own right. He was the managing editor of the paper, but before he died, he had a great career as a psychologist. He served as the managing psychologist for all Southern Nevada prisons within the Nevada Department of Prisons before he retired. And then you have Clinton Wright, of course, the photographer whose collection was really central for this project. So the slides really illustrated how key entities are connected through RDF. So as you can see here, if you're not familiar with linked data, this is a syntax called turtle. And it's a really easy way to teach as well as to write linked data. It's one of the standard syntaxes that is being used to write linked data, and I actually prefer to teach with it because some find working with RDF XML a little bit hard, and same thing with some of the other serializations. But as you can see from here, you can see these connections start to merge. With Charles West, he's a civil rights activist. You can see he was the founder of the Las Vegas Voice. He's linked to his wife, Dottie West, and their son, who served as the managing editor of the paper. And as you can see in the data, they're connected through a property called AgRelOn has spouse, and AgRelOn has child. All three, Charles, Dottie, and John, are connected to the Las Vegas Voice through employment or founding roles using properties like has employer, founder, has employee. And then we also model Clinton Wright, the photographer employed by the paper. His collection, the Clinton Wright Photographs, is linked to him as the creator and West Las Vegas, the community it documents. West Las Vegas itself is modeled as an administrative area, giving spatial context to the people and organizations in this network. This snapshot shows how people, places, organizations, and collections come together through simple RDF statements to tell a connected community story. So workflows, moving from digitization to metadata creation to knowledge graph. We begin with digitization, the process of converting physical photograph negatives into digital surrogates. This step not only preserves delicate historical materials, but also sets the stage for broader access and reuse. In this project, digitization opens the doors to deeper engagement. Corey, you're muted.
Sorry about that. Every digitization project at UNLV gets a detailed plan, and the plan comprehensively documents decisions about the collection's transformation into a digital project. The plan usually includes rights information, a review for sensitive or restricted materials, an inventory of formats and materials, assignment of appropriate digitization equipment and specifications, and a plan for metadata enhancement from whatever exists in the finding aid. So this project was a large project, and it had over 8,000 negatives in 3 primary formats with an assorted additional miscellaneous set of formats stored in additional folders. Digitization of reflective materials is a more difficult task than capturing paper or text collections or just flat printed material. And there was a significant learning curve for the students. Using the Phase 1 camera and the film kit we have in our digitization lab, students worked over about 2 years successfully digitizing the items. Next slide, please. So after the plan that I mentioned was created, students were brought into the workflow. And as previously mentioned, students are trained to capture according to procedures for the camera and to the national specifications or international specifications. They also use procedures that we've created to follow a file naming convention, and they go through significant training to understand the digitization plan and how to capture the materials. After they capture, the students review their work as a team and with their supervisor, and they check things like image quality, orientation, cropping, file structure. Due to the subjective nature of film digitization, training was a bit longer than normal, and at times we had to recapture images that were not in focus or at the right specifications. But through the process, we did work to document the progress of the project in a database called Airtable. And as we QC'd things, batches were then forwarded to a library staff member to ingest into our repository. We do use provisional metadata that comes from our archive space platform as a starting point for metadata. But before we talk in detail about the metadata work the students undertook, let's take a moment to step back and understand the overall metadata and linked data strategy developed by Darnell in his role as the strategist for digital collections metadata.
So, data modeling. With digital assets in place, the next step is to determine how we represent information they contain. Through data modeling, we identify entities and define the structure for describing them using ontologies. This diagram illustrates key modeling decisions when connecting a UNLV node, represented in red, to external authority sources via semantic relationships. The UNL entity links to Library of Congress subject headings, or LCSH, using the schema has occupation property. We link to the library name authority file, or LCNAF, using a SKOS exact match. GeoNames using either birth place or death place. And then we can also link to Wikidata using a SKOS close match. These connections reflect deliberate choices in how entities are aligned across vocabularies to support richer discovery and contextualization within the knowledge graph. Here, we're looking at how we modeled organizations using schema organizations as its base class. Depending on the type, like if it's a school or a business, we could use more specific subclasses. Each organization in our local UNL namespace is also connected to external authorities, including, again, Library of Congress's name authority file, GeoNames, and Wikidata. This lets us retain local control while aligning with broader linked data standards for interoperability and discoverability. And I want to just make this note. This framework is really designed to be very flexible. We don't have to use the Library of Congress's name authority file or Wikidata. You can use any name authority file you would like. We just happen to use that as because we are a NACO contributor and we want to make as many links as possible. Now, this slide focuses on how we establish relationships between entities, what we call connecting node to node. Using properties from schema.org and AgRelOn, we link individuals to organizations or other people. AgRelOn, if you've never heard of it, stands for Agent Relationship Ontology, and it's managed by the German National Library. Um, these relationships, whether professional, familial, social, are key to surfacing the interconnectedness of community life. And by making these connections explicit in RDF, we move beyond isolated data points and begin to model real-world context and meaning. So, once the data model is in place, it's time to put it into action. Student researchers engage with materials, describe, annotate, and enrich the collections while working closely with myself, who manages new authority records to ensure consistency and quality.
So once the high-level decisions are complete that Darnell has talked about, students are assigned batches of defined digital objects. And the students receive training from Darnell and their student supervisor. And we're not talking just about training presentations or one-offs. They are also provided with written documentation, a listserv where they can share metadata questions, and they are engaged in standing metadata meetings to share their questions and experiences with us and with each other. Metadata creation does speed up after this training, but there's always a subjective component to it. This is the cataloger's judgment. And because of that, communication, collaboration, and documentation of decisions amongst the metadata creators is really essential to the metadata quality. Along the way, as students are creating metadata, we want them to take this vital knowledge of the people and places in the photo collection that they've researched and capture things they have learned. They gain a lot of details and examples that can be used in the collection by looking in the Las Vegas Voice newspaper or in other research sources. So we challenged the students to come up with a central place where they could all look at and access each other's research. And as students do, they impressed us. They came up with an Airtable base, which is a database where they're keeping thumbnail images, notes, and links. And this has been a really important tool in enhancing entities. Darnell's going to talk now about the entity enhancement process and how that leads into metadata creation.
The metadata process begins with identifying a distinct entity, such as a person, place, or concept that needs description. The metadata creators gather relevant contextual information to enrich this entity's profile. Next, the metadata manager, like myself, creates the agent record in archive space, our archival management system, and that ensures consistent documentation. This agent record is then synced to our Special Collections and Archives portal, where it becomes part of a linked data knowledge graph, enabling enhanced discoverability. Once the entity is in the portal, its metadata is further enhanced with additional attributes, roles, and contextual details to improve discoverability. Semantic relationships between entities, such as affiliations and collaborations, are formally encoded, strengthening the overall graph structure. Metadata creators are notified when the entity is available for use. And finally, they link digital objects like images and documents to the entity, providing rich contextual access to related content. With metadata in place, we shift focus to linking, storing, and surfacing the data. This phase sets up the infrastructure that lets our work function as a knowledge graph, ready for connection, exploration, and reuse. The knowledge graph workflow begins with step one, where the triple store is configured. This enables the foundational environment for storing and querying RDF data using SPARQL. Step 2 involves loading multiple ontology RDF files into the triple store. These vocabularies define the structure of the graph and provides the terms needed to describe entities and their relationships. Step 3, the metadata manager, like myself, selects appropriate classes and properties from the established ontologies. This ensures that the data is semantically consistent and interoperable with broader linked data standards. And then finally, in step 4, RDF data is written into the triple store using a SPARQL insert statement and the turtle syntax. This format allows for clean, readable encoding of triples, making the data easier to manage and to debug as the graph evolves. So as you can see, the first step is, where we're going to configure our triple store, essentially setting up the environment that will store the data and reason over our data. We begin by creating a new repository, assigning it a descriptive name and purpose that reflects the scope of our project. This helps with management and discoverability as the work grows. For reasoning, we selected RDFS plus optimized rule set. This choice allows for lightweight inferencing, such as recognizing subclass relationships and property hierarchies without overburdening performances. This balances the idea for an evolving community-driven data like ours. Once the repository is configured, the next step is to declare the namespaces. That's the shorthand prefixes that links our data to external vocabularies and ontologies. This not only improves the readability of the RDF triple and SPARQL queries, but it also ensures consistency when referencing shared terms. By clearly defining these at the outset, we ensure that our data is both human readable and semantically inoperable. Now we get into loading ontology RDF file. This project draws on a mix of well-established semantic web standards and domain-specific vocabularies to express relationships, define classes, and ensure interoperability. We use schema.org to define common types like people, organization, and places, SKOS to model concepts drawn from community knowledge, AgRelOn to express the nuanced relationships between people and organizations, GeoNames ontology to add geographic context, RDF, RDFS, and OWL properties and classes to formally structure the data and define relationships. And then we use the XSD or the XML schema data type to standardize values like date strings and our string literals. Together, these schemas and ontologies provides the backbone of our linked data model, allowing for flexible reuse and alignment with other data sources. To model the diverse entities represented in the historic Westside, we applied a wide range of schema classes. These included people, civic structures, businesses, schools, organizations, and cultural venues, reflecting the community's complexity and vibrancy. Grouped by type, they helped us organize and interlink data in meaningful, queryable ways. As the project continues to grow, new classes and relationships will naturally emerge, deepening our ability to represent the community's story through linked data. And then in the final step, we load our structured RDF data into the triple store using a SPARQL insert query. I'm sure most of you familiar with SPARQL have used SPARQL select, SPARQL ask, and maybe even SPARQL construction to create data, but this is a way we would insert data into the triple store. So this example represents a rich entity description of Charles West. You'll notice we bring together multiple vocabularies, schema.org for the core descriptive properties like name, birth, and death details, education, affiliation, SKOS for concepts, labeling, and linking to authority sources, AgRelOn to model social and professional relationships, and of course, the UNL namespace for our local, representing our local taxonomy terms. These triples bring together biographical metadata, contextual relationships, and external references to form a well-connected, semantically rich resource. Once inserted, the data becomes queryable, linkable, and is part of the broader knowledge graph. This step bridges structured metadata and the querying power of the semantic web. So it's 12:10. All right. So this is really ends like our presentation for this section. Now we're going to move into the hands-on activity portion of this section. We shared the website. We have a supplemental website. Let me copy it again and give it to you one more time if you haven't.
I just put it in the chat.
Thank you very much. So if you guys want to follow along, we could go there. Go here. So you go there, I'll bring you to this website. It'll have general information about the project, some of our modeling decisions we've discussed, list of our class and properties used. We're going to go to the hands-on section. So let's start with activity 1. So I would like to take some time for you guys to actually work independently. Go ahead and look at this photo. And this photo is from the Marie and James B. McMillan Photograph Collection. James B. McMillan, he was the first licensed dentist, Black African-American dentist in the state of Nevada. And he was actually one of Dr. West's, one of his closest homies. So who can you identify in this photograph?
Sammy Davis, obviously.
Definitely, definitely. And for those who didn't know, this is a young picture of him. To the far left, from left to right, you can see I have a show caption button, which will then reveal the caption. And so as you can see transcribed from the back of this image, the Sands Hotel before 1962, left to right, Dr. James B. McMillan, Dr. Charles I. West, Sammy Davis Jr., and then Monsignor James B. Impey, who was the pastor of St. Joan of Arc's Catholic Church here in Las Vegas. And they presented him, Sammy Davis Jr. an Award of Merit honorary fellowship to the Sammy Davis Jr. and the Will Maston trio from the George Washington Carver Memorial Institute for outstanding contributions to the arts, humanities, and race relations. Also, to let you know, Sammy Davis Jr. was a childhood actor who was also a childhood entertainer who was also a member of that group. So if you could go down, and then I would like you guys, I'm gonna give you guys maybe 3-4 minutes to work through the part B section. And you can see we have a code box. And so you can actually replace and start typing RDF in this file. And so we'll be using through these exercises, these code boxes for you to practice typing RDF using a turtle syntax. So if you go ahead and participate in the part B, go ahead, I'll give you a few minutes to click through and the try. And then when you guys are done with that, just go ahead and just give me a thumbs up.
Darnell, for
Yes,
us that have never done this before, can you put in 1 for us? Because I
sure.
know there's probably someone sitting there looking at this going, I have no idea what to do.
Sure. And if you scroll down, I'm maybe getting a little ahead of yourself. So right here, what we're defining. So I'll just go ahead and explain this right now. Um, this box right here, we have our namespace declarations right here. This is actually in the Turtle syntax. But since SPARQL 1.1, when we write Turtle, you could either write your namespace declarations in this syntax or the SPARQL, which is usually all caps, and then there's no periods after the URIs. For this one, using this class, A is shorthand for saying RDF type. So we're basically, if you've worked with Wikidata, this is the P31 property or the instance of property equivalent. And so what I've asked you to do is replace this with the appropriate class. And as you can see from my example above in part B, the St. Joan of Arc's Catholic Church is classed as a schema organization. And so what I would do is just replace this with schema organization. And then you can see the next line. This entity also has a label, an English label with St. Joan of Arc's Catholic Church. And so that triple is complete. Now, if you guys already were successful to do that, there was a bonus challenge here where if you could find a Wikidata QID for it, and from what I've told you on how we model it, you would be able to go ahead and add that. So what I would do is just copy it, go to Wikidata, there it is. St. Joan of Arc's Catholic Church. We got that Q number. So, oops. So what we could do is just continue this and then say SKOS close match. And then in the URL, Q, and it would be WD Q number. And so right there, that's how we would have added the URI to it and stuff. And you can see up there, I've already had the WD namespace already put there ready to go and stuff. And if you append that Q number to that namespace, it would resolve to the entity in Wikidata. And you would be able to do the same thing if it was a Library of Congress record. We would use exact match, and we would then use the name authority file URI. So then it would be in a square, it'll be in brackets or like in between, like greater than, less than. All right, let's move on to the second activity. Take some time and just read through this activity. Understanding how to express structured metadata in RDF is key to building your knowledge graph. Below is an example using real entities. So you can see here goes a full turtle file with the concept. You can see the concept UNL 16527 is a SKOS concept. And then you go on the next line, it's a person. And then you see we use a SKOS pref label, West, comma space, Charles I. This is Dr. West. You can see his note. I've declared that he is in scheme. So there are two ways. This question actually came up in another session earlier today. So there are two ways to do this. Some people want to mess with quads and you get into the, name graphs and stuff. But before SPARQL 1.1 was updated, SPARQL protocol was updated, to basically separate your stuff in various collections, you would either use SKOS in scheme or you would use RDFS is defined by. We could use a name graph, but for teaching purposes and for this project, it just will just make you have to write some more lines of SPARQL code to federate the different name graphs together and stuff. And I don't really think that's necessary and stuff. So you can see all the stuff we've done. And then this example uses schema.org, SKOS, and AgRelOn vocabularies again. And then we have a breakdown of the actual triples on what it's doing. So we're in part B, we're gonna be building on what you've learned in the first activity. We're gonna build on classes from the activity one. So for this second part, I want you, using the example URIs and the classes below, I want you to write RDF statements for each entity. And for each one, use the A keyword to assign the appropriate schema class as its RDFS type, right? RDF type. I want you to add the SKOS preferred label. And then I want you to add a note so you could describe what this entity is. And so I've given you 1, 2, 3, 4, 5 examples. And really, it should only be a couple lines, and I'll do the first one for you. So we already named the UNL namespace, so I'm not going to use the full URI. I'm going to just say UNL colon 3454 is a schema person. Oops, it's supposed to be comma, colon. Oops. So the next thing I would say is this entity 3454 has a SKOS pref label space double quote Davis Sammy Jr. We'll just do something like that. I will always type it after your double quotes at Ian, because this is the English label. SKOS note. Or another thing you could do is just borrow from the wherever this URI came from, which I'm gonna do right now. And I'll just use that first sentence there. Oops. And then most importantly, I want to make sure that and tell it is in this namespace. So that is the basic, any kind of data mining or data thing, entity extraction is the first step. And so I try to always by nature, you first define the entity, then you want to class it or subclass it. You got to give it a label because technically the name is not Sammy Davis Jr. The name is UNL colon 3454 that has an English label, right? And then we have the note, and then we're telling it it's in this scheme and stuff. So this is our term. And then if I wanted to, I could go grab the NACO record, link it, go grab the wiki data. He has a Wikipedia article page, so that means there's an entity in DBpedia as well. So you can link it that way. or in any other name authority file you would want to use, you could go ahead and add that. So just continue on for this. This is some more entities. This is adding properties. Like if I wanted to add his birth date, this is a new one for you guys. So with the birth date, it would be, I'll just put 1925, but instead of typing it with an English label, we will use XSD date. Now we know that it's a date. If there were other numbers in there, we could use it with the XSD schema. There's, non-negative integers. There's like, you type it however you needed your string to be typed.
Darnell, do you want to pause and take questions from the first two?
Sure. I do not see I can't see
Okay.
the window, but
I'll read them to you. First, there's a question about, as a NACO contributor, if the NAR didn't exist for an entity in the project, would you or one of your colleagues in the library then make the NAR so that the SKOS exact match relationship could exist?
so it really just depends. Not everything in our local vocabulary warrants, or we have enough information to establish it according to the NACO standard. So it really just depends. Now, when it came to my NACO contributions, my workflow is I would create the wiki data at the same time that I'm creating the NACO. And so I would incorporate the NACO URI into the wiki data and vice versa, the wiki data URI into the NACO record.
Okay, great. Let me move to the next question. What platform are you using for your local RDF triple store?
Yeah, for me, I'm using GraphDB. And I really liked it. I spent last year comparing all these different triple store, basically independent. When the Wikimedia Foundation would hire the graph consultant to look over triple stores for the move of, out of Blaze Graph. I too, because we've been looking, we currently don't have a public endpoint for our portal link data, but this project is a different beast. The intention for this is to build web applications and semantic web search sites based off this social graph. So it serves a little different kind of purpose than the stuff in our digital portal, which is connected to works and stuff like that. This is more so with this project, we're documenting a social graph, not necessarily an agent connected to a series of works.
Okay, let me move to a question about one of the entities. This is about St. Joan of Arc Catholic Church. Would schema Catholic Church be an appropriate top-level type, or less so, since that is a subtype of the schema place?
I'm glad you asked that, because that's really a modeling decision thing, right? Like, are we talking about the place, or are we talking about like a corporate entity, right? So you really have to like wrap your head around it. What are we describing it? And so I intentionally made it an organization because there are constraints on the kinds of properties used. So if I originally, when I was going through the model, I originally was like, oh, schema has a Catholic Church, class. Perfect. And so when you go there and you go look up the actual properties there and the constraints within it, then you realize, well, that's not really what I'm talking about. I'm talking about the organization, not a location. And that's why in this example, I'm modeling it as the corporate entity, not as a location, because we could model it as a place. And according to the model, Schema Catholic Church or Schema Church, it's a building. They don't, it's not the organization, it's a building, it's a location.
So following along with that, Darnell, there's a Wikidata Q number for the Catholic Church that says it's an instance of a building, not an organization. Does close match reconcile that discrepancy?
And this is why we use close match instead of an exact match, is because sometimes we may come across an entity that is what we're talking about, but the constraints in there don't line up with I'll just say the reality of the data model itself. Like when we talk to computers, they're very literal, and this stuff really means things to us. Whereas we could just in our conversational speech, we can infer that information. Oh, Darnell's talking about the church or the congregation versus the building, so it's really working with machines and working with machine code. It's very literal. And so those kinds of issues will, you have to think about that and see how that impacts your data modeling and stuff. Any other questions? I want to give a quick SPARQL example before we run out of some time.
Yeah, go ahead. I will keep an eye on the chat.
Thank you. So with any time working with any knowledge graph, whether it's Wikidata, DBpedia, anything, and it's not your data, you probably want to like discover and play around a little bit to see what's there. So I'm going to show you two different SPARQL queries that you can use in pretty much any knowledge graph. You might have to change the syntax a little bit and add different namespace declarations. But this one is, this is querying for what types of things are in this triple store. So if I provided you with a public SPARQL endpoint of this triple store, this is what we got. And you can see all of the schema properties and stuff. Administrative organizations, bars, and pubs. So these are all the classes of types of things that I've modeled so far based off this project. Elementary schools, government organizations, hotels, and local businesses. The next one that I recommend you guys doing, if you don't know, would be, this is what properties are being used in this triple store. And so you can see all my schema properties, names, addresses, affiliations, birthday, death day. You can see I used the RDF type, so that A, that's the RDF type. And then RDFS, see also. So we'll also use that to link to other things that may be related to the entity. You can see the SKOS properties, which there's very few of them. Preferred label, alternative label, close match, exact match, a note, and end scheme. And then the rest are all the AgRelOn properties that we've used. Has colleague, has spouse, has child, has member, has parent, has step parent. If you guys haven't used AgRelOn, I would just read the ontology just for the fun, because there's some really cool stuff like that. You want to model you've been murdered by somebody, you got a way to do it. Is the muse of, my creative muse, I could model them, it's really cool and creative that way. And then, we can all search for, you can see entities. This search here, I'm actually searching using a label to see if it contains the label, and I can see West in there. So you can see I have Dottie West, John P. West, Charles West. This one gives me back all my SKOS concepts because every entity I make is a SKOS concept, and I did that intentionally because now this linked data is interoperable. You guys could load my SKOS concepts in your Alma Primo. You could load this stuff. It's not just sitting isolated, and this is why we use the SKOS. That question came up in an earlier session today too. We use SKOS so our data is interoperable because all of our library systems are using it. Whether you're looking at BibFrame, it's a SKOS concept, with the type BibFrame work or a BibFrame instance, or anything else. So we're using those standards to be interoperable. And then last thing I want to do, I want to show you actually how inserts work. So if you do insert, oops, let me erase that. So just insert like that. And so today I will do insert UNL colon 25632 is a schema colon high school. Has a SKOS pref label, Rancho High School, Las Vegas. SKOS note. We'll just say, oops, put in quotes. High school in North Las Vegas, Nevada. SKOS in scheme. It's in the UNL namespace. I could say schema address 19 Sears List Ave. Oh, excuse me. 1900. Type it as English. And then we could say schema alumni UNL 17559. And if you guys remember from the presentation earlier, UNL 17559, that is John P. West. So John P. West graduated from Rancho High School. There was also schema alumni UNL 27729. That is Harlan Freeman. She was also an alumni. And then that's all I have for right now. And then you can always add, oh, I should probably go add the inverse. So I'm down here. John P. West is already in this triple store, so I don't have to just declare him again. 17559. So John West, schema, alumni of UNL colon 25632. Now, I technically don't have to put the inverse in there because of my RDFS plus inference engine running, but it's my workflow. I always try to do the inverse properties and explicitly put it in there, because sometimes what if the reasoner doesn't work? What if, you have to turn your reasoner off because you're having performance issues, you know? So another caveat I recommend when working with this, I would define your entities first before making connections. I wouldn't make connections between nodes until you've already established the entity in the graph and stuff. So if I go run it, malformed at line 1, UNL schema. What did I do? Insert data. Or did I have, oh, maybe I should have data insert. No, insert. Let's see. That's all good. Yeah. So let me see. Go back real quick. All right, let me go back and just try it out again. Insert data. Okay, that worked. Let's see. Why is it? It's funny how it just sometimes, and you have to debug sometimes. I've done this like a million times. Sorry, folks. I miss a closing bracket. It says it at the first line.
Someone said UNL isn't defined.
Oh, it's not defined. Yeah, so it didn't. Sometimes that's weird. Sometimes it won't put your namespaces in there. So, all right. So let me go in and just add all my namespaces. So I'll have to add SKOS. There. That's why. Normally it automatically populates when you start typing, but so when I run it, you can see it's executing. Boom, those statements have been added. So if we wanted to go search for it, we could go search. I'll put it in this query. You can see it. It's already there with the full URI with the label. And then you can see all the triples that I've encoded in there and stuff. So you can see the fourth column, that's where your name graph will go. So if you guys wanted to work with quads and set up a quad store instead of the triple store, you would just add a fourth column and then you would declare your namespace. So basically, instead of putting in the SKOS in scheme, you would put that full URL in the context column and stuff. And so now you're working with your quads and name graphs and stuff. So, wow, this is perfect timing. We are right at the clock. Do we have any questions? Any more questions right now? Because if not, I would
We
like,
do.
oh, well, cool.
I do have a few that weren't answered in the chat. Corey's been going and cleaning up the chat and answering some questions. One of the ones that was private message is, would you speak briefly? Oh, wait, let me, before I answer this or send this question. Those of you that do want to take a break or run, the next session is in a different Zoom. The link is in the chat, so you can go ahead and go to that. But those that want to stay for questions, feel free to stay. We do have 15 minutes until the next session. So that question is, would you speak briefly about how you train students to create metadata?
Yeah, so for this project, they've been doing two things. They've been identifying individuals who would then be like the subject of a digital object. And they've been really I've done trainings with them on subject analysis. Most of the students, before they come to me, they have no experience working with classification schemes or controlled vocabularies and stuff. And so a part of the metadata training in general is I manage our metadata application profile, which has our modeling documentation, the controlled vocabularies that are required or recommended in our fields and stuff. And so we have ongoing training on that. And then before we start a metadata project, we have project specific metadata training. So we don't necessarily say, hey, here's the Library of Congress subject headings, have fun. We'll scope it for them. And based off of, the kind of classes of things that we're dealing with, I'll give them a subset to work with. And then as they go down that rabbit hole, navigating the hierarchies of broader terms or narrower terms, they'll lock in on the precision, and over time they become really really efficient with learning these controlled vocabularies.
I love using students. They are so smart. The next one, is it possible to use CSV file or drive data from it to SPARQL instead of overcoding?
Yeah, there is. If you look on the the resource page of the website, there is a Python script that I've written called CSV to RDF, I think it's called, or something like that. And basically you will have triples, a 3-column spreadsheet, and you could basically, it will convert it to an RDF file and stuff. And so if you've seen my maybe last year's LD4, it was either last year's LD4 or the year before. I did a SPARQL session, and that was also in there. And so what we did was you could use SPARQL construct, and then you could construct your triples and export it out as a CSV out of Wikidata's query service, and then use my Python script to convert it to an RDF file for you if you don't want to encode it.
And
But
Corey actually shared that in the chat for you,
thanks.
the converter. There was a comment, these real-time examples were very cool to see. It takes a great deal of knowledge and confidence to pull it off successfully. Just wanted to share the comments.
Thank you. Thank you.
Sometimes it's nice to have those. And then Corey answered this, but they asked if it's okay if they share your activities with colleagues.
Sure. Just give me a shout out. The stuff on this website, I gave it I believe it's an MIT license. So, you guys could, use this stuff. It's, I threw this together for this presentation. So, it's here for you guys as a resource.
And we'll say the recording should be available to anyone that's in attendance that you can share too, especially if it's on YouTube. I go back all the time and look at my YouTube videos, and it shows how many people have seen it. So that's nice to track. Let's see. Is the Airtable tracker program free? Corey also answered this, but you can go ahead and answer it again. And if there's any other questions, go ahead and get them in.
Yeah, we currently use a subscription-based Airtable just because we have multiple departments using it now, and it really helps keep us on the same page.
That is all the questions I am seeing. This was great. Thank you guys for presenting this. This was awesome.
Yeah, please. And if you guys ever want to work together, or, whether it's a wiki project, you know, we are participating in the MCO early adopters phase, so we're always open to collaborate and work with folks. So
Are your slides available on Slack?
the slides are available in your scheduler, as well as a link to the website, and then it's also embedded on the website as well.
Thank you. Thank you, everyone.